Question 9, I'm pretty sure this is chapter 6. Okay, so we're asked to determine the integral of this equation here. So what we're going to do first is we're going to try and link it with which one of these it's going to turn into. So that means that I'm looking at something that has an addition between the two. Now, that's x squared there. If I take the square root of both of these things, or everything there, then it's not going to give me x squared. So I know that it can't be anything with the square root symbol, which means it's going to turn into this one. So in order to make it work out for us, we have to work out what the value of a is. So let's get started. So, oh, a pencil. Let's try that. Okay, so this is what we've got. 1 over 2 plus 3x squared dx. Now, first thing to note that in front of this, that has a value of 1. So in order to make this have a value of 1, I need to factorize a 3 out of that denominator. Not loving the pencil. Okay, so that means that now I'm going to factorize a 3 out. 1 over 2 over 3 plus 3 over 3 x squared. So I factorized a 3 out by dividing everything by 3, which means that now I'm left with, I'm going to take this third out the front for the moment, a third of 1 over 2 over 3 plus x squared dx. So now I've made it match that. Now I've got to determine what the value of a is. So to do that, I'm going to have to say that a, maybe I'll do this as a note to the side, a squared is equal to 2 over 3, which means that a should be equal to the square root of 2 over 3. Next thing I need to do is I need to start thinking about this thing here. Now, I should have this on the numerator as well, but instead I've got 1. So that really means that this times something should equal 1. So let's work that out. This times something should equal 1. 1 equals 2 over 3, we'll say x. When this comes over, it's going to divide because currently it's multiplying. So that means that now I've got 1 divided by 2 root 3. Remember, I can express it like this or like this, meaning that this root 3 is going to come up from the bottom. And now I've got to rationalize the denominator by timesing both by root 2, which will give me root 6 over 2. Okay, so that is the constant that needs to multiply this front one so that it's equal to 1 here. So I really got 1 over 3 times 6 over 2 times the integral of 1, or now I can put it back the way it was, root 2 over root 3, bracket 2 over 3 plus x squared, close bracket. Now I can simplify this front to give me root 6 over 6. Now that I've got this, I can follow my rule. So all that's going to happen is my a value is going to go to the bottom here. So it's going to give me tan inverse 1 x divided by, our value of a is this, root 2 over root 3, meaning that this root 3 is going to get flung to the top here, plus c, and now I can simplify what I've got. I'm putting the answer over here because I'm running out of space. Tan inverse 1 root 3x over root 2 plus c. Last thing to do is rationalize the denominator. Oh, I'm putting the answer here. Oh, this is ugly. Root 6 over 6, tan inverse 1. When I times this by root 2, it will become root 6x over 2 plus some constant. That's how they've ended up with that answer.